Hey, hello everyone. So today we are going to solve this Leetcode problem 208, which is implement try, pronounced as try, and it's a prefix tree, where we have three function which will be insert, search, and starts with. The search will just search the whole word. It starts with search the um, string or word starting with that particular word. So it will just return the boolean output. So try is a data structure which is majorly used for autocomplete and spell checker functionality anywhere you'll find in the internet. So this autocomplete was basically used in Google search engine as well and many more places. It has been asked in major companies including Google. So let's jump into it. So this is a class try. Let's define this try node data structure. So it will be something as public class try node, which will contain children. So children will be of type try node only, try node children, and it will contain as end of the is last node. So boolean is last node. Okay. So these are two attributes, and now we will define this try node constructor, where we will say children is equal to new try node. So this children will be of type array. So the definition would be of type like array, and which contain 26 characters as in the alphabet. And this is last node will be basically set to be as false by default. So this is a data structure that we have defined of type try node. Okay. And now the thing is that we will be using this data structure. Uh, okay, is it so? So now we'll be using this data structure here, and it will be something like we will define try node. So we can define a constructor here as well for try, and which will basically instantiate. So try node data structure root, and this will be root is equal to new try node. Okay, so this is the instantiation of this try node object, which is root here. Okay, and now okay, so now the thing is, okay, we already have this uh, constructor here, so there is no need for this multiple definition of construction. Okay, so now we have this root, we have this data structure object all ready to perform the operation for insertion, and now we enter into the insertion. So insertion happens to be with like, this is a word which has to be inserted into this try node root. So this is a try node, which is the data structure being used for implementation of try prefix tree. So it forms a prefix tree. For every node contains alphabet characters, which is 26. So insertion, how does insertion happen? So it will be um, try node is equal to root. Now we'll take this variable, and then we will use this for loop for which will be char c colon word dot to char array, and now it will be character array, and now we will take the index of this character and the first character in the word. So int index is equal to c minus sorry, this int index is equal to c minus a, c minus a, which will give me the index of this character. So subtracting a is because a is equivalent to 97, which goes to 122, the numeric value of ASCII characters, ASCII value of these small letter characters in Java. Okay, so this is the indexing. Now we got the index of that character, and now we will be we have to insert. So we need to check if condition, if um, node dot children of that index is equal to null. In that case, if it is null, then we need to create a new node. Node is equal to new try node, and we need to new try node. This will be new try node, and okay, and this node will be node dot children index. So that particular index of that word, so that is the so the situation here is that the node dot children of that index is null. So there is no word at that particular index. So at that particular index we need to put that character. We are not talking about word, we are talking about character in that word. So we need to put that character at that particular index of a node. So index could be 1 2 3 4 5 any. So at that particular index we have created new node, and we are just pointing this variable pointer to node.children index. And if the condition is not the same, so we just I mean that is not null. Okay, so in that case we just need to uh, pass this node. So this is just a traversal variable, so which has to be moved forward, which has to be moved in the forward direction. So this is how insertion goes, and when you will be returning, you just need to make sure that node dot is last node is equal to true. That is the last node after all insertion. So that is the last node, so it has to be true. Okay, now we need to search, and now we need to start with. So let's make a new method which will basically return us try node, and its name will be search prefix. Okay, so the search prefix will take input string word. Okay, and now what will happen, so this can be called from these two. The difference between this search and starts with is just here we just need to match that particular input prefix with that word, and here we need to match the whole word with the word characters in the try node data structure. So okay, word with the character in the try node data structure. All right, so search prefix, here we go. We need to search, so logic will more or less be the same. We need to iterate, so let's copy paste. So we need to iterate on this word, see that word dot to character array. We need to get the index, and then we need to search. So if and so the root should be here. So same, this try node root should be in this temp variable where we need to search. So this node dot children dot of index is equal to null. We are not going to create, we are just going to traverse. If it is equal to null, if it is null, then return null. That's the thing. Else just go with node is equal to node dot children of index. Okay. So here we are just searching. Here searching, we need to search the whole word. So if um, here you are calling search prefix word not equal to null, and um, and uh, root dot, so root is the same, that is the only root already has. So this is the search prefix, and it is returning try node. So take this try node in a try node node is equal to search prefix word. Now you get the try node. Now this node should not be equal to null. This node should not be equal to null. And the second thing that should be like is this node dot children node not children not node dot is last word should be true. So if these both conditions are true, then return true. So last node is true and node is not equal to null. Okay, and last node is true. Then return. And what will happen is, here we have to only search with starts with any a word which exists in the form of trie data structure prefix tree. We need to just search that this prefix is present in that prefix tree. Okay, irrespective of the whole word, just the starting part of this characters are present in starting part uh, is present in the word. Okay, so here is like how it goes. We just need to check that uh, it's not returning null. We are not considering the last node to be true or not. So return this uh, search prefix word not equal to null, not equal to null question mark uh, true, else false. If it is not null, then you are returning true. If okay, if this is search prefix word, search prefix. Okay, so error is for prefix, not for if. What am I writing? Okay, so this, there is no need for this if. So if this search prefix is search prefix for this prefix which is returning is not equal to null question mark, then it should be, yeah, it should work fine. String word left hand side assignment must be variable. Okay, so it's expecting a return. So let's assign it here in the same manner, and let's check this uh, node not equal to null, and then okay, node not equal to null and return true. Okay, we have to return this. So that was all correct. It was just not having the return statement, man. Okay, so returning this search prefix not equal to null, true or false, and this method will return result of try node. So this is it, and after this return node. Okay, return true. This is also true. Let's check it whether it's working fine. So there is missing return statement in somewhere. Here it is returning true, else it has to return false. Else return false. So that's it. Uh, this is null. So if node, this is the node dot children node, which is the root, the children of particular index c minus a is equal to null, then you are inserting the new trie node. Um, hmm, it can be null as well. Okay, so if node is equal to null, cannot read field children because local 2 is null. Okay, it's not able to read the children because this local 2 is only null. The insertion of the word try, insert apple, root is equal to new try node, and this try node is already defined of children, and as last node. This children is being defined as 26, this last node is being defined. This try node, this root is of try node, and this try node root is equal to new try node. Object is already created, and then this root will be root, and then this node dot children of particular index is uh, So if it is, what if I change the condition? If it is not equal to null, then let's make it okay. All right, let's come back to this. If it is not equal to null, node is equal to node dot children of index, so it's not null. Else, just create it. Node is equal to new try node, and node traversal will still happen. Node dot children. This node is null. How can this node be null? This node is already root, and root has been created. This class should be public. Does this make any sense here? No, it doesn't make any sense. It's still the error. So node is of right here, and dot children of index is not equal to null. Null pointer exception. Let me check this code base. There's bug in the insert method. Creating a new node. So the error is, the problematic part is you're creating a new node but immediately assigning node dot children index, which is still null. Node dot children. So what should I check? Node. Okay. Then you node to the parent children array. Node dot children index not equal to null. Node is equal to node dot children index. Node dot children index is equal to new try node. Else node dot new node creation will be node dot children index is null. So node dot children node dot children this children and the index. So at that particular index, which is null, node dot children index, that new node has to be created, and then node is equal to node dot children of index. Then that will be the new node. But first the insertion has to happen in that place, and then that will become the new node. So that's it, I think. This is how this trie data structure would look like, the iteration, and it was pretty decent, and apart from I got stuck here, the creation of the new node. Anyway, so this is how it was, and this is one of the beautiful data structure which is being used in many of the places, majorly in the Google search engine and many of the autocomplete functionality. So thank you for solving and being with me in this video. See you in the next question.